Hi, how is everybody?
Good.
Good.
I'm doing good.
We're still a couple minutes early, and it looks like we only have 7 folks. I think there's supposed to be upwards of 20, so I guess I'm going to wait a minute or two to get started. But how's everybody doing? How's everybody? You have a good summer?
Yeah.
Yes, ma'am.
Good, good. Even with the COVID, yeah? Yeah.
Mhm.
So,
Mhm.
and I bet you're all so excited to be back in a math class right now, yeah? So, say that again? Okay, all right. So our big accomplishment of the summer wasn't an accomplishment of ours, but my husband and I became grandparents this summer. One of our children had our first grandchild, and it was pretty exciting. She lives in the Hudson Valley, so we were down by Middletown, New York, several times over the course of the summer.
Congratulations.
Little guy came 5 weeks early, but he's strong and healthy and growing up a storm now. So yeah, pretty
Aw.
tough. Yeah, yeah, yeah. So did anybody do anything over the top this summer? Anything noteworthy? No.
No.
So I have to apologize. I know when you originally signed up for this class, they were talking about having night classes on campus. I am not going to run this like an online class. I'm going to run this like a regular on-campus class. We're going to meet during class meeting times. I'm going to give you notes. I don't know if anybody had a chance to tool through Blackboard or not. I have handouts that I'm going to fill in for the notes. They're available there for you. If you want to take the notes as we go along, you can. If you want to just pay attention after class is over, I'm going to upload the written notes into Blackboard. And I hope everybody's all right in case there's a chance that somebody has to miss part of class. I am going to be recording the Zoom meetings, and I'm going to make those recordings into YouTube videos and link them just to this class in Blackboard, so that if you're looking at the notes and something doesn't make sense, you can kind of go to where it occurred and listen to class again. Or if something happens and you are unable to miss class, because with these once a week 3-hour classes, missing one class is like missing a week of regular hourly classes. It'll all be in Blackboard. So is everybody all right with class being recorded? Okay. All right, then let's get started by taking attendance. Well, let me tell you a little bit about myself. My name is Chris Torella. This is my 14th year as a full-time instructor's professor at Niagara County Community College. I'm an associate professor, but I have been teaching math for a very, very, very long time. Probably for about the first 10 years that I was at the college, I taught this class, and then myself and my old office mate, we both taught the first semester and the second semester of the Math for Early Education majors. At one point in time, we decided that it would probably be better for the students if one of us taught one semester and the other taught the other. So I usually teach the second semester class, but I'm not that far removed from the first semester class, and I have taught it an awful lot. It's mostly looking at arithmetic. We're going to be looking at arithmetic from a slightly different angle. I'm going to go on the assumption that everybody knows how to do arithmetic. I'm going to ask when we do math in class and on tests that you don't use a calculator, because if you're going to be a early elementary school teacher, you're going to be teaching those kids those math facts. So you kind of have to be on your toes with them and be able to do them without. But besides, so we're not going to necessarily spend that much time looking at the how-to of arithmetic, but we're going to be looking at more the why. Because I think that I was blessed throughout my educational career. I was never I never was told you must memorize the steps, but rather it was always explained to me in such a way that it made sense. So does that make sense to you folks? Okay. All right. Now, when I take attendance, usually when I have on-campus classes, I like to get to know everybody. I like to know everybody by face and name and everything. And this Zoom online venue is probably not going to be all that easy. So I'm going to ask when I call roll, if you don't just say that you're here and wave, but give us a little bit of interesting information about yourselves, whatever you want to tell us. I know in my 3 classes that met earlier today, they were all telling us what program they were in and what they were planning on doing. I'm going to go on the assumption that because this is a class, Math for Early Education majors, you're probably all in that education program. So maybe you can tell us something a little bit more than just what program you're in, okay? Leanne Barman.
Here. I don't really know. I want to be an athletic director when I'm older.
Okay, all right, very cool, very cool. Liam Brennan.
Oh, that was me. Sorry, I thought you
All right.
mispronounced me.
I was going to say, because you didn't look like a Leanna to me, but
Yeah.
question, is Leanna here? No Leanna? How about Maya Broniszewski? No Maya? Okay. How about Mackenzie Carpenter? No. I'm not doing well here. Ava Cassell?
Here.
Hi.
Hi. I'm not actually an education major. I'm a gen ed major, and I'm not sure what I want to do. So,
Okay, all right. How did they end up putting you in this class and not any of the other math classes?
well, I told my advisor that I was thinking of possibly doing this.
Okay.
So she just put me in this, but I'm not sure what I want to do.
Okay, all right. Very cool, very cool. Stephanie Flowers?
I'm going for childhood education and I would like to be a 4th grade teacher.
Okay, all right. It's always interesting to me when in this class when people are like, they want to teach a certain grade because usually you kind of teach what they tell you to teach. Long story, well, not that long a story. When my oldest child was in 1st grade, he had this woman who was like the gold standard of 1st grade teacher. She must have been teaching there for almost 20 years, and she always taught 1st grade. And then there was a change of administration at the school, and the new principal really wanted to shake things up. And so they moved her to 5th grade. And my son ended up having her for 5th grade. And it was just a total change in gears for this woman. So you can have a preference, but keep an open mind. Do you know what I mean?
Yes.
Okay. Sam Fluker?
Yeah. Hi,
Hi, how do you pronounce your last name?
Fluker.
Okay, all right. And tell us something about yourself.
I've always loved working with kids and being around kids, so I'm excited to be a teacher one day.
Okay, that's great. That's the best reason to want to be a teacher. So excellent. Darlene Ground? Darlene?
Yes.
Hi, how are you?
Hello. I'm the same. I love kids, so I feel like I want to further my education and teaching kids.
Cool. Very cool. Very cool. Autumn Hall. Autumn,
Hello.
how are you?
Good. How are you?
Good, good. And tell us something about yourself.
Hopefully one day I could become a teacher in North Carolina.
Okay. All right. So you want to move down south, get away from the snow.
Yep.
Okay. All right. All right. Naomi Harper? Naomi?
Hello.
Hi, how are you?
Good.
Good. Tell us something about yourself.
I want to become a special ed teacher.
All right. So you must be a very patient person.
Yes.
All right. I am in awe. very much know. Matthew Hudson. Matthew?
Hi,
Hi, how are you?
good, how are you?
Good. Tell us something about yourself.
I'm an education major too, and I would like to be a 5th or 6th grade teacher.
Okay. All right. Very cool. Very cool. Alexis Huston?
Houston, like
Houston. Okay.
Texas.
I don't know. Somehow I read it wrong. Sorry, honey.
No, that's fine. I prefer grade school, maybe like 1st or 2nd grade. Also, sorry in advance if you ever hear me talking. I'm in the same room as my dog, so it's a conversation with her a lot of the times. Sorry.
That's perfectly fine. My middle child just moved out of the house this spring. She got her own house. And so when she heard she was going to be working from home, she's in insurance sales, she got a dog, a pandemic dog, right? And it was this tiny little fur ball, but it was a Collie Burmese mountain mix. And it's 7 months old. So he is now like 70 pounds. And when he jumps up on me, he knocks my glasses off. So we usually try to get over there in the middle of the day and walk off some of that energy for her, because working from home with this bouncy puppy that's bigger than most adult dogs is trying. So I totally understand. What type of dog do you have?
A pit bull. Come here, Duchess. She's distracted, but
Okay.
yeah.
Very cool. Maybe she can learn some math.
Let's hope.
Yeah.
Or some manners.
Okay. All right. All right. Desiree Jacobs.
I'm here.
Hi, how are you?
Hi, I'm good.
Good. And tell us something about yourself.
I'm actually currently babysitting, but I love being around kids. I've been around kids my whole life. I worked at a elementary school helping teachers in like summer school. So that was fun. So I'm excited to learn more.
Good. Good. Rachel Color Cup?
Here.
Hi, how do you pronounce your last name?
Color Cup.
Okay. All right. How are you?
Good, how are you?
Good. Tell us something about yourself.
I've been working full-time at a daycare for the past 3 years, so pre-K.
Wow. 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 Very cool. Abby McCarthy.
Here.
Hi, how are you?
Good, how are you?
Good, good. And tell us something about yourself.
I'm actually in the teaching assistant certificate program.
Okay.
Right now I'm a teacher aide at the North Tonawanda Middle School.
Okay. All
So
right.
I'm just looking to bump up.
Very cool. Very cool. Dorothea McDonald? Dorothea? Christian McGee? Christian?
Hello.
Hi, how are you?
Good, how are you?
Good, good. And can you tell us something about yourself?
I want to be a special education teacher.
Okay. All right. All right. Very cool. Courtney Metzger? Courtney Metzger?
Here.
Hi, how are you?
I'm good. How are you?
Good. Did you want to tell us something about yourself?
I've always wanted to be a teacher. I have a little brother and he's like my best friend. So I want to work with kids when I get older.
Great. Great.
Yeah.
Melanie Pena Batista? Melanie? Celestina Preston? Celestiana?
Hi, I'm here.
How do you pronounce your first name, hon?
It's Celestinia.
Celestinia. It sounds so much prettier when you say it. How are you
Thanks.
doing?
I'm good.
Good.
How about you?
Good. Did you want to tell us something about yourself?
I'm going for early child education and going to try to become a 2nd grade teacher.
Okay. All right. Very cool. Gianna Quigliano?
Hi.
Hi, how are you?
Good. How are you?
Good, good. Could you tell us something about yourself?
I actually also work full-time in a daycare right now, so I'm going for teaching.
Okay, all right. Very busy lady. Anna Riley?
I'm here.
Hi, how are you?
Good, how are you?
Good, good. Tell us something about yourself.
I'm going for early childhood education too, and I want to be like kindergarten or first grade.
Okay, all right, very cool. Renee Retzlaff?
Here.
Hi, how are you?
Good, how are you?
Good, and can you tell us something about yourself?
I'm in the early childhood, hoping to be a pre-K teacher.
Okay, all right. Egypt Shine?
Hi,
Hi, how are you?
I'm good. How are you?
Good, good, and tell us something about yourself.
I'm a music and early childhood education major, and I want to be a music teacher.
Okay, all right. So, are you planning to go to someplace like Fredonia when you leave? And I have heard they've had a really strong music program, music ed.
Maybe. I haven't decided yet.
Okay, all right, very cool. Katie Vandermast?
Hi, I'm here.
Hi, how are you?
I'm good. How are you?
Good, good. And tell us something about yourself.
I want to be like a first or a second grade teacher, and I'm also going for early childhood.
Okay, all right. And Tiara Burwayne?
Yes, that's me.
And how are you?
I'm good.
Good, and tell us something about yourself.
My least favorite subject is actually math.
All right. You know what? I hear that a lot. So, yeah. And hopefully, by the end of the semester, you have a little bit more confidence in the subject matter. But one thing that I kind of always try to start this class with is the idea that no matter what you feel about the subject, you should never introduce something as being hard or being difficult or being dull or being boring. No matter how you feel about it, you want to introduce it as, fun and exciting and useful, because otherwise they're not going to get it. They're not going to try. Have you ever, guys, any of you ever had somebody who was kind of like, oh my God, this is awful and I hate it and it's difficult, and you're going to feel that same way too? And doesn't that attitude always make a subject worse? And it's, it's kind of like a death knell before you begin. And another thing that I wanted to tell all of you is, obviously you can only see a little part of me, but I'm a rather short person. And so when I was in college as an education major, everybody thought for sure I was going to go into elementary ed because I'm under 5 foot tall. And so they pictured me. And I was like, oh my gosh, no, because when I was in college, I had always thought that elementary education was such a responsibility. And so I'm in awe of you guys because I looked at elementary education as, oh my gosh, if you're teaching the real little kids and you mess up, Johnny might never read type of thing. I was, my major was more secondary ed because I had figured at that point in time, whatever scars they have, and you can only make it better. But I'm so impressed with anybody who wants to teach those really, really early years, that is willing to take on the responsibility of that next generation, being able to read and write and do arithmetic. So you guys are amazing. So yay, you. What I would like to do next, first of all, this is a 3-hour class. A 3-hour class is a really, really long time. Do you folks think that maybe after about an hour and a half, we should just take a 10-minute break and let everybody go and do whatever they need to do for 10 minutes and come back? Or do you want to power through and at 8:45, a little bit early? What are your thoughts?
End early for sure.
And
yeah,
you would
they end early.
Rather end early than take a break.
Yeah.
Okay, all right. I did not expect that. So give me a minute. Just before I went on Zoom, I took my phone and I set an alarm for 7:30, thinking that you folks would probably prefer to take a break. But instead, what I'll do is I'll set my phone for 8:35. And when that goes off, we'll just wrap up whatever we're doing. Sound like a plan? Okay. Now, Again, I don't want to teach this like an online class. I don't want this to be an asynchronous class where you're working on everything on your own. I want to teach it like I would a regular class, but rather than using dry erase board and document camera for notes, what I'm talking at you through is a Surface that I borrowed from the college. And so it's got a touch screen. So I'm going to be doing the note, sharing my screen with you and doing the notes there. However, you know, don't stay muted. I'm going to be looking for input from you folks throughout class. And please, 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 it's your responsibility if something is ever not clear to speak up and ask a question. Also, if I have a tendency to talk fast from time to time, if I ever start doing anything too fast, or if anything is ever not clear, please stop and ask a question. Also, I noticed in one of my other classes this morning that there was a question and a conversation going on in the chat. When I'm sharing my screen, it's difficult for me to see the chat. So if somebody does put something in a chat, could I ask everybody to please be responsible to let me know that there's something in there that I need to be attentive to, okay? What I'd like to do first is to share my screen and show you what I have for this class in Blackboard, and in doing so, go through and look through the syllabus. So first of all, is everybody comfortable with getting into Blackboard? Is everybody a little familiar with Blackboard, and can everybody find it on the college webpage? Yes?
Yes.
Okay. All right. Okay. So now this is the home page. First day information, really all that is what the first announcement was, which is the link for this Zoom meeting. I'm going to try to use that same link throughout the semester, and so don't worry about losing the email. That link will be here in Blackboard for you. Other than that, most of what we're going to look at is in content, but before we get into content, I'm going to go scooch down to the bottom. In order to send email, to send me email, or to send email to anybody else in the class, you can go through and put in my email address, but I think probably the easiest way of sending an email to somebody in class is through Blackboard. Your Blackboard email goes to your NTRIP, your T-Wolves email account. If you want to get a hold of me, you can click on the Just Me, you can click on the All Instructors Users. If I have a message to send to you folks, if I ever have to cancel class or anything like that, I'll use the All Student Users. Right now, though, I'm going to use the Select Users, because I want to show you, if you want to, when it comes to things like homeworks and activities and projects, if you want to work together with people, in here there is everybody in the class's email address. So you can click on people and send them over to Select. I am in here also. Right now what I'm going to do is I'm going to select everybody, and then you have to arrow over into the Select It. And I'm going to send in a message, welcome. And then, so that's where you put the subject, and then I'm going to type the body of the email in here, and it's going to be very short. I'm going to just say hi to everybody, and then to send the email down. Look, there's too many toolbars for all of this other stuff. Down at the bottom, you just click submit. And so hopefully everybody gets email from me just saying hi. And that's probably the easiest way to email each other. In terms of the way in which I grade, I use the Blackboard gradebook. So all of your grades will be in Blackboard over here in this My Grades. Right now, I think the only thing that's going to be in there for anybody is the your attendance grade, because you've all been here, you'll have 100 on attendance. I'm going to be using a weighted average, and I'll show you how I weight things when we get into the content. I have to apologize. I need to eliminate that Virtual Success Center because I got an email from the college today saying that that is no longer active. If anybody's familiar with Starfish, it's another way of communicating with you folks. I actually had sent Starfish emails because you weren't uploaded into Blackboard until about 6 o'clock this morning. I usually don't communicate too much through Starfish. I think midway through the semester, they ask us to send you progress report through Starfish, but otherwise I'm more likely to send you an email or do something like a phone call if I want to get in touch with you. Excuse me, I know that's rude, but I'm not used to talking all day, so my throat's going to get a little hoarse. But now let's go through. Most things for this class are in content, so I'm going to go to that content tab. To start with, let's go through and let's look at the syllabus. And I'm going to minimize this block with everybody's pictures. This is Math 108. Again, my name is Chris Torella. My office on campus is C273. No, it isn't. It's C277. I have to apologize. I didn't need to correct it. My office is C277, which is across from C273. So it's in that corridor of offices. But I'm not going to be on campus very much this semester. They really tried to discourage us from going to campus because of the COVID. It is safe if you go on to do anything like in the library or the Academic Center of Excellence, the ACE Center, or the Learning Commons or anything like that. But the fewer people on campus, the better at this stage of the game. My office hours are Monday and Wednesday and Friday from 9 to 10, and Tuesday and Thursday from 10 to 11. I have to apologize that 2 to 3 shouldn't be in there. I should have proofread this document a little bit better. I'm sorry, folks. But any day by appointment. I know that if you guys are taking this night class, if it's easier for you and you want to meet sometime later in the day, just shoot me an email and I can set up an individual Zoom meeting for you, or we can communicate through email. My email address is given, but again, it's probably easiest to email me through Blackboard. My office phone number is 614-6857. Since I'm not going to be on campus, I'm probably only going to check my office voicemail about once a day. So if you really need to get a hold of me, you're better off doing that through email than via phone. The textbook for the class is the Mathematical Reasoning for Elementary Teachers. Mr. Malazzo and myself have opted to stick with an older edition, the 7th edition, because when it changes from the 7th edition to the 8th edition, the content of the textbook does not change very much. It just makes the book more expensive. And so it ups the price. So I'm hoping that by having an older book in the bookstore selling used books, it makes it a little bit less expensive for you. There is an activity manual that goes with the textbook, and we will be doing some of the activities from the activity manual. So hopefully if you bought the book at the bookstore, it came bundled with the activity manual. There are a lot of really interesting activities in there that you might eventually find useful yourself when you're in the classroom. We won't be doing all of them. We just don't have enough time. The ones that we are doing, I will have as PDF documents in Blackboard, but the activity manual is a good investment for you. This course is broken down into a couple of objectives. We're going to start by looking at the idea of problem solving. We're going to be trying to solve a whole bunch of problems starting today. Then we're going to look at the basic algorithms for the operations of addition, subtraction, multiplication, and division. We're going to be looking at it with manipulatives. We're going to be looking at them with different bases. We're going to look at them with decimals, with percents, with fractions. A copy of the course outline from the master syllabus is given here if you want to see a little bit more detail of the topics we'll be covering. This class, we're going to have 4 hourly exams given during the course of the semester. Because we only meet once a week, I am going to have those tests off outside of class time. So you'll be given, a couple of days during the course of the week in which to complete them. They will be in Blackboard. There will be a couple of different types of questions. There will be some numeric questions, but there's also going to be a lot of like essay type questions where you type your answers, and questions where you have to draw diagrams. If it's something like a handwritten math problem or a diagram that you have to draw, you'll be uploading those into Dropbox and Blackboard. And as it gets closer to that first exam, I will show you how to do that. Class participation is important. I've never taken away from students' grades for lack of participation, but if somebody is really shows that they're actively involved in class, I'm more likely to round up. The homework, in all my other classes, the homework is online in my math lab, but because of the nature of this course, the homework will be taken out of your textbook. Previously, when I taught this course on campus, I had assignments due like every day as we went through the material. But because again, it's this once a week, 3-hour class, I'm having all of the assignments for each chapter due on a given day. And so you can see that the chapter 1 homework is due on the 15th, the chapter 2 on the 13th, and so on. So that all of the homework problems are listed here. COVID policies, again, will be meeting in Zoom, and the Zoom meetings will be mandatory. And when it comes to something like a test or quiz, you need to show all of your work and submit it in Blackboard. I guess it must be later on. In all my other syllabi, here we go. Down at the bottom, the way your grade is determined, test will be 50% of your grade. The final exam will be 15% of the grade. The homework will be 35% of your grade. Letter grades are assigned with the scale that's shown there. If anybody wants to opt to take this class pass-fail, SU, in order to get an S, you would need to have an average of 65 or higher. Right now, the way the rules are at the college, each instructor or professor can set their own threshold for that. Last semester, there was rumblings from administration that they wanted to standardize it. If it does get standardized and I have to change that number, I will let you folks know. However, because this is a course that's required for your major, I think that none of you would really be well served by changing this to an SU grade. You're probably better taking it for a letter grade. And if anything happens to anybody during the course of the semester and they need to, they can't complete the course, as long as you have a passing average and you reach out to me, you can take an incomplete and we can make arrangements for you to finish the course on your own. Other concerns, and these other concerns were all given to me to put in the syllabus through academic affairs. So I apologize if you've taken other classes today, you've probably heard all of this. If anybody has any accessibility concerns, you need to, and if you need anything like extended time on a test or anything like that, you need to call the phone number that's given here and talk to Stephen Burns about getting accommodations. In terms of if anybody needs a note taker or needs to record the class, again, like I said earlier, all of the notes that I give, I will at the end of class post in Blackboard, and every class will be recorded. So, I mean, if you want to use a smart pen or something like that to record the class, that's fine, but I will also be recording every class. If you need any extra help, on campus, there's the Academic Center for Excellence, the ACE Center. During regular times, They have drop-in tutoring. I do believe that this semester, I'm not sure if they're going to have that much drop-in tutoring, but rather that you make an appointment and meet with a tutor virtually online. Right now, we don't have a complete schedule for them. I did get a schedule today in an email from the A Center, and I will post that for just this first week. I will email that to all of you after class. Academic policy, don't cheat. If you cheat, you'll get a 0 on whatever assignment it is. If somebody cheats a second time, then academic affairs gets involved, and you fail the course, you take another course. In this course, Math for Education majors, I have had some issues with the homework. I just want to make sure that everybody's clear, and let me stop sharing and look at you as I say this. I want to make sure with everybody that you know that there is a significant difference between working together on homework, which is fine, and copying. You'll find as you progress in your teaching career, especially in something like math, it's very easy to tell when one person did the homework and passed their paper around and everybody copied. The silly things like careless mistakes. I can't believe that 5 intelligent college students working together would be able to say something like 100 plus 100 is 100. Typographical errors, that the same thing that shows up for 3 or 4 different papers. I know that it was copied and not work done together. If it's an essay question and you're asked, if it's a question where you're asked to talk to the student or to explain what's done, if 3 or 4 papers have word for word the exact same answers, that's cheating, that's copying, that's not working together. And so just pay attention, and hopefully you're all familiar with the line that exists between working together and just sharing your work with someone to copy. Yes? Everybody okay with that? Okay. Then going back to that syllabus. Computer usage, obviously, it's expected that you all have a computer that you can use in class. If anybody has any technical problems, if your computer goes down and all of a sudden you can't do anything, you know, call my office, leave a phone number, and I'll call you back and talk to you. If your internet's down, anything like that. I do know that at the beginning of the COVID, in the middle of the spring semester, when everybody was forced to go online, the State University SUNY made computers available, Chromebooks and the like, for colleges to loan out to students that have those technical problems. If something comes up and you need to borrow a computer, you know, call OIT or get in touch with me. Also, if your Wi-Fi is weak at any point in time, feel free to go on campus and make use of the Wi-Fi and the Learning Commons in the ACE Center. And also at the beginning of the COVID, the OIT, the technical people at instructional technology people at the college, informational technology, I apologize, made the Wi-Fi on campus stronger so that you can access the internet in the parking lot. I know that while the weather's good, there are tables in the courtyard, tables outside where you can do work, or, you know, if you sit in your car or whatever, but that's another place where you can access the internet if you're having a hard time at home. Let's see, we talked about Starfish already. We talked about attendance already. We talked about the fact that class is being recorded. Does anybody have questions about any of these policies or is there anything that you might have heard earlier in the day from other professors that I forgot to mention? Any questions or comments or anything? I'm going to take that as a no. Please do me a favor and go through and read through all the fine print. A lot of the language is stuff that academic affairs gave us to put in. So a lot of the language is college policy, and you need to pay attention to that. Read through. Usually I have a tear off at the bottom of the last page that I ask people to sign that they've read through the syllabus and are familiar with the policies and agree to abide by them. Because I'm not giving you a paper copy, I ask that you please read it and send me an email telling me that, okay? So, everybody all right so far? Everybody know where to find things in Blackboard? Everybody, see where the list of homework is, the due dates and all of that. Then I'm going to go back into Blackboard. And again, I have an outline for the notes that we will be filling in. We'll start looking at the chapter 1 notes today. Hopefully we'll get through a good chunk of that first chapter on problem solving today. In terms of Zoom information, just like in that first day information, that announcement, there's information about the class Zoom, and there's also information about the class office hour. The office hour will be held through Zoom. It's going to be Monday, Wednesday, Friday from 9 to 10, and Tuesday, Thursday from 10 to 11. And what I'm going to be doing is sitting at my desk with Zoom open. And so this is going to be the link that I've given all of my classes for office hour. Again, that's my generic Zoom link. If you ever want to meet with me outside of class, send me an email and I'll set up an email meeting with you, and it will also be through that link. Okay. Also in content, in this folder, completed notes, as we go through and fill in the notes, I'm going to annotate a Word document that I have, and I will save it after every class and upload the written on filled in notes. I will also in that folder put links to the YouTube video, which will house the recording of class. Tests and quizzes will be in this folder, and right now there is nothing there, but there will be a drop box for each one for you to submit your answers. Again, the activities that we will be doing in class, I will have as a PDF in this activity folder. The reason I do that is because, again, I want to be able to write on and annotate the activities as we go through and do them in class. And down here, there's a how to submit the assignments in Dropbox. And as I'm looking, I need to add another folder. I will, before next class, have a folder for you to submit your homework assignments in. So everybody all right with all of this? Any questions? Any questions? Okay, all right, then let's go through and let's start looking at the notes for that first chapter, chapter 1. And before I forget, we meet on Mondays. Next Monday, Labor Day is a holiday. So hopefully everybody's aware that next Monday we will not have class because of the Labor Day holiday. Our next class will be September 14th, so you're going to want to have a good head start on most of that homework so that if you have questions on any of them, you can ask about them in class. But again, the first chapter deals an awful lot with problem solving, and the first section at the first chapter throws out a bunch of problems and asks you to come up with your own ways of trying to solve them. And so I'm going to look at this first question. It says, the Tweety and Sylvester Pet Store sells only cats and birds. It has 22 animals. The animals have 76 feet. How many of the animals are cats? And how many are birds? So the store only has cats and birds. Is everybody all right if we go on the assumption that all of the cats have 4 feet and all of the birds have 2 feet? There's 22 animals. Between all of them, there are 76 feet. How many of them are cats and how many of them are birds? I'm going to shut up for about 5 minutes and ask you folks to go ahead and work on this. Try to come up with a way to figure out how many of those pets are cats and how many of them are birds. So, does everybody have at least the numbers of the problems written down to try? 76 feet, 22 animals, cats and birds. I'm going to be quiet. I'm going to ask you all to unmute yourselves and discuss what you think might be interesting approaches and how you might do this problem. Anybody look at algebraically, want to pull out those variables and solve an equation, which would be fine, except probably not with early elementary school kids. Try to come up with something that you think an elementary student might.
Do you want us to explain it or do you want us to just do it?
Let's give everybody about a couple minutes to just do it and then explain your approaches, okay?
Okay. Mm-hmm.
All right. And I guess if we want to, we can interchange cats and dogs if there's anybody who doesn't like cats in the group. Oh, no. I'm going to have to exit this for a minute because this version of Word is not letting me write on it. Give me a second. There we go. All right, what are you folks getting? How many cats, how many birds? Anybody want to volunteer an answer? Anybody get anything?
I got 18 cats and 4 birds.
Okay, so let's look. 18 cats. Each cat has 4 feet. So 18 times 4 would be, let's see, 4 times 8 is 32, 72 feet. 4 birds, each bird has 2 feet. So that's 8. So that adds up to 80 feet. So now it's a little bit high, but it gets us to one good way of problem solving. We could go through and guess and check. And being that that number's high, is everybody all right that it's probably smaller than 18 cats and more than 4 birds? Does anybody else have an answer?
16 cats and 6 birds.
16 cats, 6 birds. And so let's see, 16 times 4. Well, 6 times 4 is 24. And then 40 and that extra 20 would be 64. 6 birds each have 2 feet. So that would give me 12 feet. And bingo, we've got 76 feet. How'd you get it?
I just literally just plug numbers in, times it by 4, times it by 2, till it got close.
So you did a guess and check type of thing.
Yeah,
Okay.
yeah.
All right, did anybody do it a different way?
I did pictures.
Who did a picture?
I did.
What type of picture did you draw?
So I just drew like a circle with 4 feet and then like another one with like 2 feet.
And so you drew 22 circles?
16.
Okay, 16 cats and 6 birds. Let's see, 1, 2,
Yeah, I had 5 birds though.
8, 9, 10.
I don't know how I had 5 birds, but
That's all right. 13, 14, 15, 16, 1, 2, 3, 4, 5. And this is, we're going to see when we get to problem solving strategies, we're going to revisit this question. And it's something that the authors of the textbook present as a method that a child might use to solve it, that I honestly want to say until I started teaching this course would never have thought of. And it's the idea that, well, everybody has at least 2 feet. So if I put 2 feet on everybody, that would be 22 animals with 2 feet, would be 44 feet, and that's not enough. So we'll start turning some of them into cats, and we'll have to keep on adding 2 more, counting up until we get to that 16 cats and 6 birds. And that's a very creative method of solving. Could you picture a child doing that, drawing a picture and saying, okay, well, let me pretend everybody starts with 2 feet. That's not enough. Let's start turning some of the cats into birds. So sort of a different approach. Anybody else have a different approach besides those? Did anybody introduce variables and do it in kind of a algebraic manner? We'll be looking at that as a possibility. And then the other thing in terms of doing guess and check, we could have started with the 18 cats and the 4 birds, and we could have made a table and kind of just gone, okay, 18 cats was too many, so let's try 17 cats and 5 birds, and work our way through in a systematic way like that. Interesting problem, kind of fun. Let's look at the next couple of problems. Next one says, if I triple a number and add 6, the result is 30. What was the original number?
2.
2. And if the original number is 2, whoops, I gotta turn my pen back on. If the original number is 2, the first thing we're going to do is we're going to triple the number, so we'll multiply it by 3, and that gives me 6. And then when I take that and add 6, I'm supposed to get 30. The 2.
Oh, I read that wrong.
You know what? Honestly, can I tell you something? I promise I will never throw anybody on the bus. I want to hear what's going on in your heads, and I appreciate the input. So 2 is a little bit small. Does anybody have another idea?
8.
8.
8.
8. So if the number is 8, when I triple 8, I get 24. And then when I add 6 to that, I do get 30. So I think 8 is going to be our number. How did you get it?
I subtracted 6 from 30 and I got 24
Yeah.
and divided 3
Yeah,
by
that's
that.
what I did.
And so that's another problem strategy, solving strategy that we're going to be looking at in a little bit. And the idea of working backwards. Sometimes with something like this, you're better off trying to work backwards. Next one says, oh, I am having so much trouble with spatial issues in Zoom. I'm sorry, folks. Next one says that we've got this pattern of circles, and we want to fill them in with the numbers 2, 3, 4, 5, 6. We want to use each number once, and we want to fill them in such a way that the answer horizontally is the same as the answer vertically. Any ideas?
I'm sorry, could you restate the problem? I'm having trouble seeing it, the Word document clearly.
Oh, I apologize. Let me see if
It probably is just bad connection on my end.
okay. I'm trying to make it bigger, and it's not letting. Oh, there we go. Is that any better?
Sure. Yep.
So we've got these circles, and please do me a favor. If something's not clear, speak up and let me know. I was telling my other classes earlier today over the summer, my daughter took a class that wasn't supposed to be online, but became online because of COVID. And rather than writing on the screen, the teacher was in front of a camera writing her notes. And my daughter said that the camera was perfectly focused on the woman's hand and not the writing. The writing was blurry and she couldn't read a darn thing. And if you can't read what I'm writing, it does you absolutely no good. So if my penmanship is too bad or too small, or if it's too blurry, thank you for speaking up. Again, I think that part of what you need to learn in your college experience is that you need to speak up for yourself. I appreciate that. So what we want to do is we want to fill in these circles. We want to use each number once, 2, 3, 4, 5, and 6. And we want to do it in such ways that the sum along the horizontal is the same as the sum along the vertical. Anybody have a arrangement that works?
I did 3, 4, and 5 in one row, and 2, 4, and 6 in the other row.
So, oops, I gotta go back and pick my pen again. So you did 3, 4, 5, and 2, 4, 6.
Mm-hmm.
And so this way, 3 plus 4 is 7, plus 5 is 12. 2 plus 4 is 6, plus 6 is 12. Great. Is that the only answer? Did anybody get a different one?
I got a different one.
And what did you get?
I did 2, 6, and 5 across.
2, 6, 5 across, and
then 4 and 3 in the other
4
one.
and 3 here. So let's see. 2 plus 6 is 8, plus 5 is 13. 4 plus 6 is 10, plus 3 is also 13. So that works. Did anybody else? Get another one.
So for the vertical, I got 4, 2, and 5.
4, 2, and 5.
And then 3, 2, and 6.
And so let's see, 4 plus 2 is 6, plus 5 is 11. 3 plus 2 is 5, plus 6 is also 11. Excuse me. Oh, okay. My phone was making noise and I thought it was something that it wasn't, so I apologize for that. So that also works. Will any other arrangement work? Let's see, we've got, if 4 is in the middle, we could pair the other numbers. 3 and 5 is 8, 2 and 6 is 8. If 6 is in the middle, we could pair the other numbers. 3 and 4 is 7, 2 and 5 is 7. If 2 is in the middle, we can pair the other numbers. 3 and 6 is 9, 4 and 5 is 9. If I put 5 in the middle, is there a way of pairing the other numbers so that we get the same total each with the ones that remain? Or if I put the 3 in the middle, is there a way of pairing the other numbers so that we get the same totals?
What if I do?
I'm thinking not, but is everybody all right with the idea that with this problem there was more than one correct way of doing it, and so we have to really look at more than one possibility sometimes? Yes?
Yes.
Next question. Lynn has 9 coins with a total value of 48 cents. What coins does Zin have? So there's 9 coins and they have to add up to 48 cents. What possible coin combinations could they have? What are you folks coming up with?
I got 3 dimes, 3 nickels, and 3 pennies.
I got the same thing.
And let's see. 3 dimes would be 30 cents. 3 nickels would be 15 cents. 3 pennies would be 3 cents. And that adds up to 48 cents. Did anybody get any other total to give you 48 cents?
I did a quarter, 2 dimes, and 3 pennies.
1 quarter would be 25 cents. And 2 dimes would be 20 cents. And 3 pennies would be 3 cents. So that indeed adds up to the 48 cents. But I think this time there's only 6 coins altogether. And we knew that this person.
Oh,
9
okay.
coins.
That's my fault.
So no worries, no worries. Does how those of you who got 3 dimes, 3 nickels, and 3 pennies, how'd you do it? What was the thought process? How did you come up with that combination of coins? What was your thought process? Explain.
I just drew a picture diagram again.
So you drew 9 coins?
I drew like the 3 nickels, the 3 dimes, and the 3 pennies.
And it, you know, that was just your first attempt and it worked?
Yeah, that was actually my first attempt.
Okay, anybody else have anything other than a good strategy, drawing that picture and just, you know, luck of getting it right the first time?
Well, I knew that like you were gonna need a nickel, at least one, because like you didn't have enough coins to be able to have 8 pennies with the 48. So I just started with there, and then I just kept subtracting it down until I figured out like how many coins.
So you knew you needed 1 nickel and 3
pennies
to get the 8.
And I just kept figuring it out from there until I got the right amount of coins.
Great. Anybody else have a different approach, or does that sound like enough things for now? If that's all right, the next place in the second section of this first chapter, the next place that the author goes are Paulia's problem-solving principles. And I promise you this is something that I'm going to ask you to know. You know, you might have a quiz at some point in time where it's just, you know, fill in the blank, type in, you know, what are Paulia's problem-solving principles. You might be asked to explain Paulia's solving principles on that first test. And first, there are steps that really are a good approach to solving any problem. First step, and I think someone asked for clarification on one of the problems because I couldn't see. Does it make sense that that first step in solving any problem would have to be to understand the problem? In terms of understanding the problem, what are some things we have to worry about? Don't we have to first be able to know all of the vocabulary that's used? What do each of the words mean? Don't we have to know what we're looking for? In terms of knowing what we're looking for, understanding the vocabulary, it might be important to be able to restate the problem, put it in your own words. Sometimes, like we saw with cats and the birds, sometimes a diagram to show us what we're looking for, and the coins is helpful. And then other things we need to ask ourselves is there enough information? Or is there any extra information that we don't need, extraneous information? Is there anything that any of you can think of that I've left out in this description of understanding the problem? Any ideas? I'm thinking right at the top, what I should have added first and glazed over is the idea that you have to read carefully, right? So enough on understanding the problem? Then what Palia says is the second step that we have to have is we have to devise a plan. In order to devise a plan, we have to come up with some sort of strategy. Looking back at those few problems that we've just solved, what might be some strategies that you might suggest for problem solving?
Guess and check.
Guess and check.
Read the problem more than once.
Reread. What else did we do?
Picture diagram.
Picture. Diagram. I think for one, a couple of you worked backwards, yes? I think we talked about the possibility with guess and check of making a list. We alluded to the idea of using algebra, which you wouldn't always do, but from time to time, introducing a variable is a helpful thing. Any other ideas? Has anybody ever tried to solve a problem by eliminating the impossible? Which is something that hopefully we'll get to before the end of the night. I don't know if we'll get through all of them, but hopefully some of them. Any other ideas, folks? Possible strategies? Should I just add a ... to say this isn't a final list, but just a starting list?
Yeah.
Okay, so after you come out with a strategy, a plan of action, what do you think you need to do?
Check your work.
How about even before you check your work, maybe do your work? Carry out the plan? Carry out the plan, check to make sure it works. And I apologize, my penmanship is deteriorating because I'm writing on an up and down surface with a stylus, which is not my strong point. Can you guys still read this, or is this getting too sloppy?
That's fine.
I'm fine.
Okay. And if it doesn't work, you have to be willing to start over. Be willing to change your plan if needed. And then the last step, which is something that I don't think I personally don't always do often enough, and it's the idea of look back. Look back. What did you learn from the problem? And also that idea of, as we were working on those different problems together, different people had different strategies. Could you have used another strategy? And like we saw with the circle problem, is there more than one correct answer? But going through and doing that, making sure you understand what's being asked, being open to having different approaches to solving a problem. And like we saw with those problems that we looked at, different people had different approaches, and it wasn't that one was necessarily than the other. And what's easier for one person to understand might not be for another person. Usually there's more than one mathematically correct way of doing something. Going through, doing your plan, being careful, checking your work, and if it doesn't work, being willing to go back and start over again without getting frustrated. You know, you have to encourage kids to be able to do that. And then when you're done, it isn't always just getting that answer, but it's looking at what you learned in the process. Did you pick up any reasoning skills? Can you think your way through? Did you learn something? Can you explain it to somebody else? Okay? So those are Polly's problem-solving strategies. And so now we're going to take a little bit and look at some specific problem-solving, Polly's method of problem-solving. Now we're going to look at a couple of different strategies with different problems. I think we looked a little bit already at the idea of guess and check. And so you're going to find, I believe there might be some of these in your homework in terms of guess and check. What we've got here is a triangle of numbers, and what's supposed to happen is the corners are supposed to be the sum of the two adjacent numbers. So over here I have 6 and 2. So what number should be in this top corner? 8. Over here I have 6 and 12. What number should be in this left corner?
18.
18. And then over here with 2 and 12, this last entry should be
14.
14. And that way, when we know the numbers that are being added, it's pretty straightforward to get the corners. What if instead we know the corner numbers and we have to work backwards and see what was added? Is there anybody in the group of you who think that guess and check might be a way of coming up?
Yeah.
Yeah. So I need some guesses. What numbers would you like to try to put where? Any ideas? And again, don't be afraid to make a mistake because we're just guessing and we're going to learn from our guesses. I have to apologize. I heard something, but I couldn't make it out. Anybody have any numbers that they want? Bye.
Five.
Five where?
The very first line on the left.
On the left here, five?
Yeah.
Okay, so if that's five, in order to add up to 11, this would have to be?
6.
6. And in order to add up to 15, this would have to be? 9. Does that give me my 16? 5 and 9? I don't think so. So let's go through and let's try another guess. Let's see, we had 16, 11, 15. Did you want to try maybe putting the 5 down here?
Yeah.
And if 5 is here,
And 5 goes there.
What would I need to add to 15?
1.
Maybe 10. And what would I have to add to get the 11?
6.
6. And do the 6 and 10 give us the 16? Yes. And so guessing and checking, we could get our way through to that solution. That one okay?
Yep.
Okay. Next one's a little dicier. I have to change the pen into an arrow to be able to slide up. And right now, Word is freezing on me and not letting me. So, well, okay. Problem, but now, no, it's not solved. Now we've got it. Now it's working. This time, we want to use number 4 times. And so number 4 times means we're going to have 4, 4, 4, 4. And we want to fill in with 3 different operations in between them. Multiplication, addition, subtraction, division. First time we want to go through and get a total of 0. And anybody thinking of a way that we could take those 4 4s and add, subtract, multiply, divide in any order to get a total of 0? Again, we're just guessing and checking, so I'm open to ideas. Any thoughts? What are you folks thinking? All those 4s, we want to fill in the spaces with the 3 different operations to get a total, the final answer to be 0. What are you thinking? Oh, I missed something in the chat. What are you thinking?
I was thinking maybe like you multiply first, then divide, then subtract.
So you're thinking 4 times 4, which would be 16, divided by 4 would be 4, minus 4 would be 0. I think that works. What are you folks thinking?
Yeah.
And it follows our order of operations, right? Because left to right, first we'd multiply, then we divide, and then we'd subtract. Anybody have another way of getting that 0? I'm thinking we could interchange the division and multiplication. 4 divided by 4 is 1, times 4 is 4, minus 4 would also give us 0. Anybody get another way of getting to that 4? I'm sorry, getting to that 0. Can you do the same type of thing with those 4 4s? 3 different operations to get you to a 1.
I'll do 4 plus 4.
4 plus 4 would be 8.
Divided by 4.
Divided by 4.
Oh, we have to do 3 steps? Oh, never mind.
You have to use 3 different operations. Okay, so we'll get rid of the divided by? Or no?
No, it would already give me 1.
I've overclicked things and it's going on straight. Yikes.
I would do, I think I'm ready.
Okay.
I would do 4 divided by 4 times 4 minus 4.
4 divided by 4 times 4 minus 4.
Yeah.
I think that got us to 0 before. This time we want to get a total of
1.
1.
What if we did
Go ahead.
4 plus 4?
8,
then minus 4. Would be 4, and then 4 divided by 4 would be 1.
I think that would work, but I think with that one, I have to apologize, you guys. I just froze this thing up. Is anybody good with unfreezing Word?
Nope.
Uh-oh. But I'm agreeing with you. 4 plus 4 would be 8, minus 4 would be 4, and then divided by 4. But I think we'd need parentheses around this too, wouldn't we? Because of order of operations, normally you have to divide before you add and subtract. So is everybody all right? In order to do this, we have to kind of also consider using our order of operations. Okay. I'm sorry, I've messed up. I'm like that little kid that pressed too many buttons. Yikes. What I'm going to end up doing is switching to a whiteboard board and trying to resuscitate what I messed up but right now I messed up pretty bad. So that gave us, let's see, in order to get 1, we said it was 4 plus 4 minus 4. And then we divided that by 4, and that took us to 1. Any ideas on how, same type of thing with those 4 4s, you can get to 2, to 3, and I'm going to leave you folks with that problem for about 3 minutes and see if I can get that Word document to work again. So are you guys all right if I leave you for a couple minutes trying to fill in those last 2 and telling and if we'll I'll get back to you in a minute. Okay?
Yeah.
Okay, it's back to working for me, and I apologize for that. Did anybody get a total of 2?
I think I did.
What'd you do?
4 divided by 4 plus 1 times 4.
4 divided by 4. I think the only numbers we can use are 4. So we can't add that 1. So I'm not sure that that's going to work. Anybody else have an idea? I think it's the eraser that's messing me up, and I've got to stop picking it. Anybody have any ideas for 2? I'm thinking maybe if we start in the middle with 4 plus 4, that would be 8. And if we take that 8 and divide it by 4, we'll get 2. And so then 4 minus that 2 would give us 2. Make sense? And any ideas on getting 3?
I did 4 times 4 minus 4 divided by 4.
So 4 times 4 is 16. When you subtract 4, it gives you 12. Divided by 4 will give you 3. I think that's great. Everybody in agreement with that one?
Yep.
I want to say when I was trying to figure these out on my own, because it had been a while since I had last looked at these problems, I think the one that was hardest for me to get is 2. But now I have a question for you. When do you think you want to use that guess and check? When would you advise to use guess and check?
Like which number or?
Just in general, any type of problem. What type of problems would you suggest somebody use guess and check? What would you, when would you, what type of problem would that be the first thing that you reach for?
These ones?
All problems?
When somebody says all problems?
Yeah. Problem.
All problems if you don't see another possibility? How's that sound? Sometimes it's a good method of last resort. Sometimes if you don't see something else, it's a good method of first resort, yes? So, guess and check. I think everybody can probably wrap their minds around guess and check pretty easily. I'm going to try to save that whiteboard and then add another one. And I'm going to go freehand because that document is frozen. I'll figure out a way of uploading all of this. Second strategy is make a list. And so the problem that I'm looking at here is you have pennies, nickels, and dimes. I'm going to take 3 coins. How many different sums are possible? And so we want to try to solve this one by making an orderly list. So the way that I would make this list, I would start with, okay, I could have pennies, I could have nickels, and I could have dimes. And I have 3 coins. So one way is 3 pennies, 0 nickels, 0 dimes, and that would add to 3 cents. Then what else could I have? Maybe 2 pennies, 1 nickel, no dimes. What would that add to?
7 cents.
7 cents. And then let's see, I could still have 2 pennies, no nickels, and 1 dime. What would that give me?
12 cents.
12 cents. Is there any other way of having 2 pennies? I don't think so. So then we could have 1 penny. If I have 1 penny, what could I have? 2 nickels, no dimes. What would that be?
11.
11 cents.
7 cents. And then I could have 1 penny, 1 nickel, 1 dime. What would that be?
16 cents.
16 cents. And then I could have 1 penny, no nickels, and 2 dimes, which would be
21 cents.
21 cents. And is there any other way of having 1 penny?
No.
No. So we've got all the possibilities with 3 pennies, all the possibilities with 2 pennies, all the possibilities with 1 penny. So now we could have no pennies. If I have no pennies, what could I have?
2 nickels and a dime.
2 nickels and 1 dime would be 20 cents. Thank you. I can count. What else could we have? No pennies. 1 nickel, 2 dimes, which would be 20, I think 5 cents.
Oh, 25 cents. 25 cents.
And I've run out of room, so I'm going to carry my list over here. Pennies, nickels, dimes. We could have no pennies. Let's see, what else could we have? We could have 3 nickels and no dimes, which would be
15 cents.
15 cents. Any other way of having no pennies? Maybe no nickels and 3 dimes?
30 cents.
30 cents. And let's see. I have 1 with 3 pennies, 1 with 3 nickels, 1 with 3 dimes, 2 with 2 pennies, 2 with 2 nickels, 2 with 2 dimes. I have 3 with 1 penny, 3 with 1 nickel, 3 with 1 dime. I have 4 with no pennies, 4 with no nickels, 4 with no dimes. Does it look like that's about as complete a list as we can get?
Yep.
So how many different sums are there? 1, 2,
10.
So there's 10 sums. And do you see how making the list of possibilities helps? Yes? Let's save that one and add another. Next one is how many ways can you arrange the letters E-A-T? How many different arrangements are there of those 3 letters? I'll do the hard one. C-A-T. Can anybody think of another way that we could arrange those letters?
ACT.
A-C-C-T. Anything else?
TAC.
T-A-C. So we've got one way with the letter C first. Is there any other way with the C first?
CTA.
C-T-A, I like it. Any other ones with C first? What is that A?
ATC.
ATC would be another one with A first. And is there another one with T first?
TCA.
T-C-A. And I think by the way we made our list organized, the C's first, the A's first together, the T's first together, I think we've covered all our bases, yes? And so we'd have 6 ways of doing it. And so then the next question I'm going to ask is, when do you think you should make a list? When should you start a list?
When they ask to arrange.
You're looking for arrangements, yeah.
The sum of something?
Say that again?
Like the sum, when they're asking you to find the sum of.
Find possible sums. And when there's only a finite number of possibilities, if there was an infinite number of possibilities, I don't think I would start making a list. Does that make sense? So this idea, this strategy of making a list, okay for everybody? I'm gonna add another page. Next strategy is to draw a diagram. And, oh, this is a long drawn out problem. You know what I'm gonna do? Let's see. I also have the notes as a PDF. Maybe can I open that? And, here, draw a diagram, go to this page. And see if it lets me write on the PDF. No, not the whiteboard. No, it's not going to let me, but can everybody read the problem for a minute, and then I'll pull up the whiteboard and try to draw a diagram. It says we've got Joe, Steve, Mike, Kevin, and Ed all running in a race. Kevin finishes 5 seconds before Ed. Mike finishes 6 seconds after Joe. Steve finishes 8 seconds after Joe. Ed finishes 2 seconds before Mike. In what order did they finish? Can anybody picture drawing a diagram to go through and try to solve this one? Can I move this whiteboard? Ah! Yeah, I can move the whiteboard around. What might you draw? Any ideas?
Maybe like a line.
Okay, so let's draw a line. And maybe we can put slash marks on it to represent seconds. And let's see. First thing we know is Kevin is 5 seconds before Ed. So I don't know, what do you think? Should we maybe put Ed somewhere in the middle? And put Kevin 5 ahead? 1, 2, 3, 4, 5. How's that look?
Looks good.
And then let's see. What else do we know? No, Mike compared to Joe. Steve compared to Joe, but we don't have either of them involved yet. But let's see, we know Ed is 2 seconds before Mike.
Yep.
So should we put Mike in here somewhere? Where would you put him?
Put him in front of Ed.
The other side of Ed? We're saying that this is like front.
Yeah, the front side on
This
the left.
back. So that Ed is before Mike. And then let's see, what else do we know? Mike is 6 seconds after Joe. So Joe would be in here somewhere, yes?
Yes.
1, 2, 3, 4, 5, 6. So I'll put J there for Joe. And let's see, where's Steve fit into all of this? 8 behind Joe. 1, 2, 3, 4, 5, 6, 7, 8. And so there's Steve. What do you think? Does putting them all in a line using hash marks per second take that kind of complicated sounding problem and turn it somewhat easier?
Yes.
Yeah. Okay, so what order did they finish in? First is Kevin. Second is Joe. Third is Ed. Fourth is Mike. And fifth is Steve. And does the picture help?
Yes.
Let's see. Let's add another whiteboard and look at this next one that's suggested to draw a picture. And this one says, where did my whiteboard go? I lost it, you guys. There it is. How can you place 10 stools against the walls in a room with 4 walls so that there's the same number of stools against each wall? We're drawing a diagram. So are you guys all right if I make the room square? And we have 10 stools, and we want to place the stools in the room so that each wall has the same number of stools. Where are you putting them?
I don't know if anybody else is having the issue, but I can't hear.
You can't hear?
It's not working.
I can hear her. She can hear you.
Yeah. Is your volume turned down, hon? Who's not hearing? Who's not hearing? Darlene. Anybody else having a problem hearing?
No.
No. No.
The only thing I can think to suggest is for her to try to log out and log back in. Does anybody know any other better attempt at trying to get around that in Zoom? And while we're trying to figure this out, has anybody come up with a picture? With the 10 stools against the 4 walls.
2 stools on each wall and then 1 in each corner. So like the one in the top left corner and the one in the bottom right corner.
So 1 in this corner and 1 in this corner?
Yep.
And so now each wall has 3 stools on it? I like it. What does everybody else think? Life is good? And I think in terms of this drawing a diagram, we talked about that with that initial cat and bird problem. Everybody okay with different instances where using to solve a problem would be beneficial? And let's see. Is Darlene back in yet?
Yes.
Yes, Darlene's back. Darlene, can you hear now? Where is she? Where is she? I don't see her. Oh, she's connecting to the audio. Should we wait a minute? Oh. Darlene, can you hear us?
Yes, I can hear now.
Okay, good, 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 good. And you know, it's that sometimes I'm not always the world's best with technology, but sometimes when something doesn't work, I kind of just log out, log back in, kick it. And you know, it's kind of like unplug or something like that, and it seems to help. But obviously this Word document froze on me, so I promise I will scan all of this in somehow for you, but I might leave it go till the morning. But drawing a diagram, all right, for everybody. So then the next one is the idea of looking for a pattern and seeing if you can find a pattern. There are several of these in one of the assignments. And I know that when my children were in elementary school, they frequently came home with worksheets with this idea. Do you guys remember seeing worksheets where you had to look for a pattern and fill in the missing numbers? How's everybody doing at seeing patterns here? Let's see. Let's add another page and we'll call this the patterns. The first one we have is 2, 5, 8, 11, 14. Does anybody see a pattern there? And we go from one number to the next.
Add 3.
Add 3. And over here, we're adding 3 and adding 3. So what would the next 3 numbers be?
17, 20, 23.
And that one was pretty straightforward. Let's look at 10, 11, 13, 16, 20. And again, I want 3 more numbers. Does anybody see a pattern there?
Each time you add another one.
1 plus 1, 2 plus 3.
So explain it a little bit more to me, please.
So the first time you added 1, then the second time you added 2, the third time 3, the fourth time 4.
So this should be,
Add 25,
and then,
31,
and then,
38.
beautiful. Does everybody else see the pattern with that one?
Mm-hmm.
Next one's interesting. It's actually got a special name. Let's see if I can spell it. Fibonacci. And it goes 0, 1, 1, 2, 3, 5, 8. And anybody see a pattern here?
You're adding each number with the last number. So 1 plus 1 is 2, 1 plus 1 is 1, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, and so on.
So the next one would be?
13.
5 plus 3, 8 would be 13. And then 8 plus 13 would be?
21.
21. And then 13 plus 21 would be?
34.
34. And can everybody see that pattern progress? Next one I have 1, 2, 4, 8, 16. And again, I want 3 more numbers.
Times 2.
Okay, each time we're doubling, beautiful. And so when we're multiplying to go from one to the other, it's sometimes referred to as a geometric series. Up here, when you add the same thing each time, it's sometimes referred to as an arithmetic series. But this time we're doubling. And so let's see, 1 times 2, 2 times 2, 4 times 2, 8 times 2. The next one, 16 times 2 would give us
32.
Beautiful. And then 32 times 2 would give us
64.
and then 64 times 2 would give us
128.
128. Great. Next one, let's see if I can fit one more on here. What if I have 1, 4, 9, 16, 25. Does anybody notice a pattern there? Or anything at all about those numbers?
They're odd.
One's odd, the 3's odd, the 25's odd. I think the 4 and the 16 are even. We're not doing any, when we go from one number to the next, you know, I don't think are we adding something? Or is there another way maybe of coming up with those numbers?
They're all each number multiplied by 2. Like 5 times 5 is 25.
So can I call them, I'm going to pull out a word that might be a blast from the past. Are they your squares? Your perfect squares? This is 1 squared, this is 2 squared, this is 3 squared, 4 squared, 5 squared. So what do you think those next 3 numbers are going to be?
36, 49, and 64.
Beautiful. And so that pattern maybe wasn't quite as obvious, but looking at them, we could find similarities between the numbers and carry on with the pattern. Sound good?
Yep.
So next strategy that we're going to look at is making a table. Oh, Lord. I have never had such difficulties with this. There we go, make a table. And so I'm going to look at how many dots in each of the following. And so I'm going to have and we're going to try to use a table to organize our thoughts and see if we can generalize from there. So we're going to have the entry the total number of dots. What we're totaling, and then the number of dots. So in the first entry, is everybody all right? There are 2 dots, and so we have 2. In the second entry, we have those 2 dots, and then we added 3 more to give us 5. In the third entry, we had 2 plus 3, and then we added 3 more to get 8. Everybody kind of following? So in the fourth one, we have 2 plus, this time we're adding 3 columns of 3, which gives us 11. What would our fifth one look like? If you were to draw it, what do you think we should draw? Two dots and then what? Any ideas?
4 columns of 3.
4 columns of 3? And so what we'd have is 2 plus 4 3s, which would give us 14. And so what do you think the 10th entry would be?
Two and then 9 columns of 3.
So it would be 2 and 9 groups of 3, which would give us
29.
29. What would the 100th entry be? We'd have 2 plus how many columns of 3?
99.
2 plus 99 columns of 3. And so that would give us, let's see, I think that's just going to be a little bit under 300, maybe something like 299. And could we generalize to say that we have 2 plus 1 less than the entry that we're looking for times 3? And use that idea of a variable to generalize. What do you think? Did making the table help us come up with that rule? And over here, this idea of using a table to generalize gets us to that 6th strategy, which is going to be to use a variable. Using a variable from the preceding problem, we'd have 2 plus n minus 1 times 3. So what if I ask you what is the 80th odd number? If we tried to make a table to help us get there, the first odd number is 1. The second odd, and that's just 1. The second odd number is 3, and we got that by adding 2. The third odd number is 5, and we got that by adding another 2. And you see, it's kind of like what we had done with the preceding one. What we've got here, if I wanted the fourth odd number, wouldn't that be 7, which would be 1 plus 3 2's? And so if I say the nth odd number, wouldn't it be 1 plus n minus 1 times 2? And so the 80th would be 1 plus 79 times 2. Let's see, 79 times 2, I think is 158. And so the 80th odd number would be 159. Does that make sense? Any questions? If not, I want to do one more somewhat like this. And I want you to find the 300th number in the pattern. And I've got 7, 11, 15, 19, 23. How does this compare to those other ones? Is it like the other ones? Do we add the same difference each time? If so, what are we adding?
4.
4. So we've got 7, we've got 7 plus 4, we've got 7 plus 4 plus 4. So can't we say in general that the nth entry is going to be 7 plus n minus 1 times 4? In terms of what we did with the preceding problems, does that make sense? Everybody okay with me or not? Thumbs up? Yeah? I'm not seeing everybody, just some of everybody. So I'm gonna try to stop the share for a minute. Everybody okay with where that idea of n minus 1 times, oh, you guys are awesome, thank you. You guys are better with understanding the math than I am with doing the technology tonight. Sorry about that, folks. And so for the 300th, it would be 7 plus, let's see, 300 minus 1 times 4, or 7 plus 299 times 4, Let's see, what do you get when you take 299 times 4? Let's see, 4 times 9 is 36. 36 and 3 is 39. 8 and 3 is 11. So that gives me 7 plus 1196. Ooh, sorry about that. Which is, what is that? 1,203. And we have a total of, from the textbook, like 13 different strategies to look at. And I'm looking at my phone and it's about 1/4 after. So let's just do one more strategy. And then shall we call it a night a little bit early because this is our first night of class? Or do you want to try to push, work your way through 2 more? We see how we go after 1 more? This next one's kind of a special one, kind of an interesting one. And it's called looking at special cases. And the special case that I'd like to look at is something that's called Pascal's triangle. And Pascal's triangle is just interesting arrangement of numbers that has so many different patterns in it. It's really something that's quite useful. Have any of you ever taken advanced algebra and trig class where you've looked at binomial expansion, where you've looked at something like x plus y to a power and had to come up with all of the different coefficients and everything? Pascal's triangle is used with that. Have any of you ever heard of Pascal's triangle? No. With Pascal's triangle, we're going to make a triangle formation of numbers. And the first is actually called row 0. In row 0, we're going to just put a 1. And then the next row, row 1, we're going to have 2 1s. And in any row, we're going to have 1s at the beginning and the end. So for row 2, we'll have a 1 first and a 1 last. And then for the middle, and each row has 1 additional entry. And these middle entries are always the sum of the 2 diagonally above it. And so here in the middle, 1 plus 1 would give me 2. So my second row would be 1, 2, 1. My third row is going to start with a 1. It's going to end with a 1. This row, instead of having 3 numbers in it, will have 4. What would those middle numbers be? Well, if I add the entries diagonally above it, 1 plus 2 is 3. 2 plus 1 is 3. What would the fourth row have? Start and end with 1. What would this entry have to be? 1 and 3 would give me
4.
4. In the middle, 3 and 3 would give me
6.
6. Next, 3 and 1 would give me
4.
4. let's do one more. The fifth entry would be start and end with 1. The fifth row, pardon me. What would the entries be after that? 1 and 4, 5. Then
9.
10. 6 and 4 would be 10. And then 5. And then 1. So what patterns do you notice? The number of entries is always 1 higher than the row numbers. We've got 1 edge along the edges. If you look row 2, if I look at going along this diagonal, it's all 1. Going along this diagonal, what do I have? 1, 2, 3, 4, 5. Going along this diagonal, I think that might have been one of those number patterns that we had where 1 plus 2 is 3, plus 3, 6, plus 4, 10. And we'd find a different pattern along each diagonal. But what's also really cool is if I look at the sum of the rows. First sum is 1. Second sum would be 1 plus 1 is 2. Next sum, 1 plus 2 plus 1 is
3. Oh, 4.
4. Thank you. Next sum, 1 plus 3 plus 3 plus 1 is
8.
What's the next sum?
16.
16. Any guesses to what the next sum will be?
32.
32. And you notice each time we're doubling them. And if we want to, when we look at the sums, row 1 is 2 to the first or 2. Row 2 is 2 to the second or 4. Row 3 is 2 to the third. Row 4 is 2 to the fourth. Row 5 would be the product 2 to the fifth. Row 0. Has anybody ever seen 0 used as an exponent? Anything to a 0 power, well, almost anything to a 0 power, is always defined to equal 1. And so your sums turned out to be your powers of 2. Isn't that a cool pattern? And as you look at it, next semester, if you take Math 109, the second semester of this class, when you start looking at probabilities, you're going to find that the numbers in there aren't just the sum of the 2 above it, but they're also related to something that's a little bit headier idea, and that's the idea of combinations. And so this Pascal's triangle has all sorts of different special cases in it. And I lied. I'm going to do one more trick after this. So one more strategy after this. Give you one more problem to try to wrap your minds around it. Are you guys going to kill me if I do one more besides special cases?
No.
Okay. Next one is going to be the idea of using algebra. And the example that we're going to look at using algebra, we're going to do something that's referred to as Gauss's, G-A-U-S-S-E-S, trick. And Gauss was a famous mathematician, and the story goes that when he was in elementary school, the teacher gave a tedious assignment to the class and asked them to find the sum of all the numbers from 1 to 100. And so the teacher was looking for the total of 1 plus 2 plus 3 plus all the way up to plus 98 plus 99 plus 100. I think the story goes he was in 3rd or 4th grade when they were given this challenge. How long do you think it would take you to find that total?
A while.
A while?
Yeah.
But this young man, Gauss, who turned out again to be a famous mathematician, came up with a shortcut and was able to come up with the total in only a couple of minutes. And his shortcut involved using a variable. Is everybody all right? I'm going to say that the total of those numbers is something, we'll call it n. Now, I'm going to take that list and I'm going to rewrite it 100 plus 99 plus 98 plus, and down here, what would I have? Plus 3 plus 2 plus 1. And that's the same total, so that should also equal n, right? Everybody with me so far? Does anybody notice anything about the way those numbers line up? What happens when you add down? 1 plus 100 is 101.
Mm-hmm.
What's 2 plus 99?
100.
101? What's 3 plus 98?
101.
101. And as I go through, wouldn't each of those, when I reverse the order, wouldn't each of those also add up to 101?
Yep.
And that's not going to give, that's going to give me twice the total, right? 2n? So I've got all of these 101s. How many 101s would I have written there?
100.
So wouldn't that be 101 times 100? And doesn't that equal to twice my total?
Yep.
So wouldn't my total be 101 times 100, whoops, divided by 2?
Yep.
And so that would give me, let's see, 10100 divided by 2 would give me 5,050.
Mm-hmm.
How cool is that? Just a quicker way of coming up with that sum. And so you can use that same pattern to find any sum of what we call an arithmetic series, which just means you're adding the same value each time. And so, giving you one last pattern, I'm going to ask you folks to use Gauss's trick. find the sum of the first 50 terms of 4 plus 6 plus 8 plus So what was Gauss's trick? It was to write the list backwards, right?
Yep.
So writing backwards over here, we have 4 plus 6 plus 8. But do we know where it ends?
No.
But do we have the skill? Could we find what the 50th term is?
Yes.
Isn't that kind of like what we did with the previous, when we took the first term plus n minus 1 times the difference?
Yep.
So our first term is 4. And how many terms are we looking for? 50. So 50 minus 1 would be 49. And over here, what's the difference between each term? What are we adding each time?
2.
2. That gives me 4 plus, does everybody remember order of operations? We'd have to do this multiplication before we did that addition. 49 times 2 would be 98. And so our last term would be 102. And so that's going to be our n. This time we're going to do it in reverse. So that would be what, 102 plus 100 plus going down. What does each of these columns add up to? 4 plus 102 is?
106.
6 plus 100 is 106. And so it looks like each time we're going to add up to 106. And so let's see, we'd have 106 written 50 times. Give us twice our total. So our final answer would be what we get when we take 106 times 50. And then, whoa, this pen and I are not friends anymore. 106 times 50. Oh, Lord. The eraser was the kiss of death before. 106 times 50 divided by 2. I'm going to erase and rewrite that whole second part of that line because it got ugly. I'm sorry. 106 times 50. It's doing it again, you guys. Divided by 2. And are you folks all right if I leave the arithmetic there? I think I worked this out previously and I got something like
2,650.
650. Thank you. Thank you for doing the arithmetic for me. Can you do the writing for me too? 6, 5. Oh, there, we got it. It worked. So can everybody kind of wrap their minds about using this formula, the first number times 1 less than what you're looking for times the difference to find a missing term if we know we're adding the same thing every time, and using this Gauss's trick then to find the total. Is everybody all right with that?
No.
No. Okay. Let's, should we go back and do it again? should we do another one? Should we try it with another series of numbers or no? Make sure we got it down before we call it a day. Let's find the sum of, okay, what do you want your first number to be?
13.
13. And how much do you want to add on each time? We have 3 each time. 13 plus 16 plus 19 plus, and how many of these numbers do you want to add? $50 of them, 20 of them, 100 of them, how many do you want to add?
50 of them.
Find the sum of 50 terms of. And so we're going to use a variable, we'll call it n, uppercase N, and that's going to be the total. Are you with me so far?
Yes.
Does it make sense that now we also have to find the last number? How are we going to find the last number? Well, we're starting with 13. And
Work backwards.
adding, how much do we add each time?
3.
3. And if we're going for 50 terms, wouldn't we add that 3 49 more times? Does that make sense?
Yes.
So 3 times 49 is, let's see, 3 times 50 is 150. So that'll be 147. And so the 50th term would be 160. So is everybody comfortable finding that last term?
Yeah.
So then we're going to reverse it and add 160. Before that would be 157, taking away the 3, right? Plus 154. And we go all the way down until the last one is 13. Is everybody comfortable with reversing the order? So far, so good? And now Gauss's trick is to add down. 13 plus 160 is 173. 16 plus 157, wow, that's also 173. And each time I add down, shouldn't I get 173? With me so far?
Yep.
That's not my total though, because I'm adding each of the numbers twice. So that's 2 times my total. So 2 times my total, I'm going to have 173. And let's see, how many 173s am I going to have? 50 of them?
Yep.
And so now to find my total, I'm going to divide by 2. And so my total is 173 times 50 divided by 2. Any better? And is everybody all right if I leave the arithmetic for you to do out?
Yep.
Conceptually, can everybody sort of follow those algebraic steps that we were taking? Is it a little bit better? Is there anybody who's still, do you want it back up again? I'm sorry. I just wanted to take a quick look at your faces, but Uh, is it a little bit better this time?
Yeah, I think I just got to practice it on my own just
Yes,
to
you
make
do. And
sense in my own head.
I think there's going to be some of those in the homework. Now, before I send you on your merry way, use algebra, I want to just pull up my textbook and let you know how far we got in that chapter 1, so that if you want to get a head start on the homework, we've covered in chapter 1 the content through, you didn't do the pigeonhole principle. The problems on page 28. So we've done sections 1, 2, and 1, 3. And so if I can go back to that Reddit Word document that I froze, 1, 1, 1, 2, 1, 3, the first half of that homework, the first 3 pages of that homework, we've kind of gone over. If you want to read ahead and try those next 3 pages, again, I'm not going to see you next week, but I'm going to see you in 2 weeks.
Okay.
Couple questions I have for you before I let you go. Is this going through the problems like this on the whiteboard or the Word document, if I can get it to work, filling in the notes, is this close enough to being in class for you folks? Do you feel engaged enough? Do you feel like you can learn like this? Is it close enough to the classroom experience?
I like it like this, yeah, because I kind of need the notes.
Kicked me out. Sorry.
Did I kick somebody out?
No, I got kicked out because it froze and it kicked me out. I'm sorry.
Okay, you're back though?
Yes.
All right. So if we hold class like this will be okay for you folks.
Yeah.
And you're comfortable enough. If I go too fast, tell me and I slow down. If I go too slow and you're bored, yell at me and I'll speed up. If you have questions in between times, if you're working from the book and you feel like you're banging your head against the wall, please send me an email. Please make use of my Zoom office hour. If I know a couple of you said you're working in daycares and things like that, if you can't make my Zoom office hour and emailing back and forth isn't doing it for you, send me an email and I can Zoom one-on-one with you, okay? I want you to know that even though we're not meeting in person, you are not learning this on your own. I'm here for you no matter what, okay? Life is good?
Yep.
Okay, my alarm went off. So I promised you guys we'd end when my alarm went off. So have a good Labor Day next week. Thank you, Union, because that's what Labor Day is all about, right? And I'll see you the following Monday, all right?
I just had a quick question.
Turn off one.
Is this the right book?
This one?
Yeah.
Yeah, it's the 7th edition. And again, there are newer editions out there, but we just—
And it comes with this?
Yes.
Okay.
And in an ideal world, we would have, if I didn't get into a battle with the technology, we would have gotten a little further and we would have done a couple of the activities from the activity manual today.
That's okay. I just want to make sure I can go inside and look at some of this stuff.
Yeah. And if you want to have the note packet that I'm filling in, it's there in Blackboard printed out. Okay. All right. In an ideal world, if we were on campus, I would have them printed up for you.
Right.
I figured the next best thing is to have them available for you in Blackboard. Okay.
Okay. Thank you.
All right. Anybody else have any other questions on anything else? So far, so good? All right. So we'll see you guys in 2 weeks. Have a mathematical holiday next Monday. All right.
Have a good Labor Day.
You too. Bye-bye.
Bye.
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 Bye. Bye-bye.
Bye.